All right, so in this third and final video, we're going to take a look at synthesizing all four of these scenarios. Okay, so 1 through 4. I'm going to scroll down to this page and we're going to basically copy and paste them end to end, right? So the first one was speeding up in the plus direction. So on my x of t graph here, I'm going to draw something like that, right? A concave up curve. Then we're going to slow down in the x direction. Well, that's a concave down. Something like that, right? Then we are going to, speed up in the negative direction, right? And also note, right here, we're not moving because the slope is zero speed. So now we're going to speed up in the other direction, backwards. We're going to turn around and go back. So it's going to go like, whoops. Something like that, right? A concave down slope. And now we're going to slow down in that negative direction. Something like that. Back down to zero. It should be somewhat symmetric, but I'm not an artist. Whatever. So we have here 4 regions, right? We have, here's one, there's one, and there's the last 2, right? And yes, you can think of this point and this point as where the continuity changes, right? So now let's draw the v of t. Well, in the first one, which by the way was number 1, this was 2, 3, and 4. Number 1, we're speeding up in the plus direction. So for velocity, we're going from 0, and we're increasing at a constant rate up to some maximum speed, where that discontinuity occurs, by the way. And then, once we reach that maximum speed, right here at some position, then we start to slow down to 0. So slowing down to 0 on the v of t graph means we do the same thing back to 0. That's not quite on there. Let's do it like this. There, that's closer. Okay. At a constant rate, back down to 0. Okay. And in section 3, we are speeding up in the negative direction. So the negative direction tells you that it has to be down here. This is negative v, right? Up here is positive, down here is negative. And if it's speeding up, that means that the magnitude of the velocity has to be increasing. So guess what? It's just a continuation of that line. Right? It's one solid straight line, assuming that, of course, this is a nice continuously uniform curve. But for right now, that's a straight line. It's just going from the positive side to the negative side, right? And then in section 4, we are decelerating or slowing down to a stop in the negative direction to 0. Okay? Something like that. All right, and now the acceleration versus time graph for section 1. We have a positive acceleration, right? We're speeding up. The slope of v of t is positive. So I don't know where it is exactly, but it's positive, somewhere up there. Now for section 2, the slope is negative, still in the positive direction, but the delta v is negative, so it's somewhere down here, right? There's a discontinuity in the a of t graph, right? And again, yes, I know, right here, it should be how do I draw it? Should be a tiny little curve, right, at that point, which means that this should be, right? It's not technically a discontinuity, but for all intents and purposes, it is, right? It very quickly goes from this acceleration to this one, right? When you stop and turn around, right? Or rather, when you accelerate and then decelerate. Sorry. In section 3, we continue on at that same magnitude, that same rate of acceleration, right? It's the same slope. And in section 4, again, it's a positive slope. Just like over here in section 1, it's the exact same thing. So that means that it's a positive slope, just like in section 1, right? It's a positive acceleration, rather, just like in section 1, right? And so that's our A of t graph. And so this entire object was, again, starting from rest, speeding up in the plus direction, slowing down to a stop, still in the plus direction, stopping, turning around, going the other way, speeding up to some maximum speed, then slowing down to a stop, right? That's what's happening in this entire curve, okay? I hope you've gained a better understanding of the graphical analysis between x, v, and t, right? And can better, well, discern what's going on when you see one of these graphs, all right? Thanks for watching.